record. Monday's recording did not happen, so today is Wednesday, and we're going to talk about CLang and GCC. I had a question from a student who's on a Mac and say, hey, what about CLang? Can I use CLang for what we're doing? Yeah, kind of, sort of. But there's some differences. Now, this is a category that you are going to need to know what is the tool chain that you'll be working on. Okay. Now, let's explain what CLang is compared to the GNU compiler suite. Okay. Now, this kind of thing is in documentation somewhere on the planet, but a clear definition of why you use one versus the other, I have not found. Okay, so if you find something, let me know. Okay. GCC and basically anything from the GNU people compiles to something called GAS, which is the GNU Assembler. Okay, this is a standard that works on any hardware. Okay, so I can take the output of this assembler and put it on any chip, and then I take a hardware assembler that goes from GAS to Llvm or the Intel chipset or the MIPS chipset or whatever. Okay, so what we're getting at in what we're doing and learning the debugger, we are still one level away from actual hardware. Okay, I want to stress that. We're still not at the hardware level yet. Okay, we'll get there. CLang compiles to something called the low-level virtual machine. Think Java. You write Java, you don't care. Java works on anything, right? As long as you have the right version of the right Llvm on your target platform of choice. Okay, so think Llvm, I got it for Windows, I got it for Mac, I got it for Linux. As long as they're the same version, I can take my Java code, run it here, run it there, run it there. That makes sense? Okay. Llvm is similar, but not the same. Llvm is basically authored by Apple and a lot of contributions by Google. Where is it used? All of Apple's products use CLang. So if you're going to be an iOS developer, you're going to be an Apple Mac OS developer, you're going to be using CLang. What happens is they have other computer languages that they use, like Swift and whatever else they come up with this week. But they all have the option to go down to this Llvm. Okay. This is can you run it on Linux? Yes. You can run Llvm on Linux. It's a different tool chain that generates a different low-level assembler. I'll just call it LLAS, okay, low-level assembler. It creates a different flavor of this low level. But why would somebody use that when this GNU stuff is free? Speed. When you start compiling with a generic tool that works across everything, you're going to lose clock cycles in overhead. If you have the money and you want your Linux box to scream, go buy the Intel C++ compiler. $50,000 a year for the privilege of renting it. You have to pay that every year. But you will see an order of magnitude speed increase on your Linux box. But now you're stuck. Anytime you want to add something, you have to recompile to source code to make it run. Okay. Advantages, disadvantages. The Intel tool chain and CLang are in this category that we don't touch on, and you probably won't even get near in your computer science education unless you go into specific hardware engineering. They are working on this Intel and CLang and some of these other folks where you're actually compiling to a physical chip. So think of it as, I'm going to write my code for a specific router. I'm going to make this chip for the router. I write my code, compile it. Now I have this chip. Now all this is happening because of what's going on with China right now and the chip shortage. So there's been this huge funding increase into low-level chip development across the entire spectrum. It's opening up a whole world that wasn't even thought of 5 years ago. Okay. It's actually quite amazing to see what's going on in this space. It's hard to keep up, but what you're going to see is smaller and smaller, faster and faster. So when you get a job and say, yeah, I can write C++, okay, what's your tool chain? That's a question you'll want to ask depending on where you go, because they may have a tool chain that is specific to their hardware. And you'll have to spend a month or two to learn that tool chain. We teach one tool chain. It's not the only tool chain, okay? So CLang is used in some very high speed, high throughput types of places. So let me see how this behaves today. I'm going to bring this up and I'm going to use, I'm just going to type in CLang at CERN. Everybody familiar with CERN? The super collider? Notice what they do. They actually have, now I actually tried to install this on the Jeremy box. There's way too much stuff that I need to put on there. And I go, well, that's not going to work. So I'm going to have to open another browser. So I'll open this one, CLang at CERN. Now, CLang is a REPL. How many familiar with that? REPL. REPL. Read, evaluate, print, loop thing. So open your browser and go to Replit, REPL.IP, or Replit.com, okay? Let's go to start creating. Let's see here. Oh, bummer. I don't want to create a login. But basically, let's use another one that we will get to. Let me see if I can find the link. There it is. Godbolt. .org or com. I think it's org. This is one guy, and he does this stuff on the side. Pretty sharp. So here's your C++ code. This is what it's doing, and it's showing you what's going on at assembler. But which assembler are we looking at? Is this Intel assembler? Is this MIPS? No, this is the gas assembler, okay? The GNU assembler, the one that's generic for all platforms. I changed my source code here. Let's pick one, and let's pick another language. let's look at C and run it, save and load it. And you can do the local. He did some clever things with, if you want to learn some tricky things about web dev, poke around on this website. He did some really cool stuff. So we'll use C, and let's see here. Let's do diffu. So here's to assembler, and then I can pick different types of outputs here, providing the code is complex enough. Okay. So, but this, so it lets you actually explore at these things, but not all languages are in here. Okay. There is a lot of this stuff, like this one here, Zig. I'm not sure what Zig is. I think it's an optimized version of C and C++, so you don't get memory buffer overflow errors, kind of like where Rust is going. But if you look in here for these languages, we'll be playing with this to some extent. There's Rust, okay? And we see the output for Rust, and you can see what's going on here. Now, where are we? We're using a tool chain, so we can choose between our tool chains, because he does have CLang in there. So you can choose between the GNU compiler suite or CLang, okay? But you won't find the Intel compiler in there. It's a free site. Who's going to pay the 50 grand to get the Intel compiler? When I worked at Foster's, we had the IBM C compiler that was specific for IBM hardware. Yeah, it was way faster than the GNU. I mean, even for the smallest project, it was significantly faster. Okay. So where are we going with this? Well, I want to show you what we'll be doing. So I basically want to explain CLang and GCC. If you want CLang on Linux, you can do it. Okay. Apt-get install CLang. What version? 6, 7, 8, 9, 10. It's up to 15 now. Okay. So you can choose your versions of code and compilers. So let's use C, and let's see, it's all G. It's going to force me to G12 here. So you can click on, you play around with it. So this is kind of like what we're doing in the Jupyter Notebook, except it's all web mouse click. Okay, it's very similar to what we're doing. It's just that we're using the GNU toolchain. I want to mention that about the CLang, that you can do it if you really want to use CLang on your machine. Ask yourself why. Well, I want to be an iOS developer. Well, that's a really good reason. Okay, I want to work for Apple. That's a really good reason. Okay, Google, they use CLang to some extent, but not as much as you would think. So this part is, this is one of the websites that will be on our little cheat sheet here, is to be able to take your C code. Well, that was interesting. Yep. What's that mean? Today, we are going to walk through some C code that is not really super good, but it's going to show you how to bring in a piece of code that you write as a library, compile it, and we're going to look at it in the debugger. Okay, we're going to do that in class today. Your homework will be to do something similar, and I'll write the parameters or the edges of what that's going to be, it's basically going to be the same thing with a slight variation. Okay, so you're going to write a C header and a C file. You're going to include that C header. You're going to compile it, and you're going to see the output. Okay, and we're going to walk through these sort of things and saying, okay, now that we have these values, where are they in memory? How do I look at that exact value and change it? Hey, I want to change my loop count to 20 in the debugger. How do I do that? That's where we're headed. Okay, but before we get there, I want to show you a couple of things. And let's see, how do I want to do this? Maybe I'll do it this way and bring it over here. And then bring it up into the browser. What I want is, okay, here we go. I want this one. You know, maybe I should just bring in a bootable. Okay, I'll put it over here. This is a student. This is what you should be doing. Taking notes and putting it on a static website free at github.io. Your goal is a job, and the way you get your job is a portfolio. Prove to me you know what you know. Start by creating a blog, a learning log, weblog, whatever you want to call it. Like in your case, you get a perfect one. How I'm learning Rust, what I'm doing. This is my failure. This is my success. Why is this important? Because you're going to be Googled, and they're going to look at you, and they're going to see what you've been up to. This will come up because it's GitHub.io. You don't have to put everything on there. You can make things private, okay? So you can put your successes if you want. But the idea is, this is free. You can get a static website generator at GitHub.io, and you can keep track of what you've been doing. Now, it's really hard to stress that, but let me tell you about one of my guest speakers. His name is Salvador. He was a student here. Tremendous interest in robotics and other such things. Started getting into security and doing some advanced security research, and figured out how to do an exploit with Samsung Pay that he could get a free Coke from a vending machine. He demoed all this at DEF CON. He's making way more than I am now. He's also bilingual or trilingual. Maybe Portuguese is in there, I don't know, but Spanish and English for sure. He's been all over the world talking about this Samsung exploit using Samsung Pay. Even the bigwigs from Samsung came and took him out to dinner and said, we're not going to fix that because nobody's going to exploit that. Well, that was at that time. They've had to revisit those words. Okay. He was a guest speaker for my final projects class a few years back. And I asked him, knowing what you know now, having traveled the world, what would you do differently? I'd start a blog of explaining what I'm learning. He says, this is how I've gotten my jobs. He's a consultant, high-paid security researcher. You don't have to wait to learn from that mistake when somebody's giving you some free advice. I said, you know, that's a really good piece of advice in today of portfolio building. And it also helps you keep track of blocks of time. There's still a bias in HR that if you're unemployed for longer than 6 months, you're considered unemployable. Is that true? Of course not. So what do you do with that 6 months of time? Prove you're learning something. Document it. Volunteer. So here's something free to do. And what is a static website? Well, they're simple. You can do one on the Jeremy box if you want to get started. Okay. Static website generators. Pick one. All right. What language would you like? Let's use one in C. There we go. There's 3 of them. So you can actually write your code in C and deploy it and have your own website. Or you can do Java, or you can do C++, or you can pick Go. One of my other students is way up in security. He says, yeah, Go is really what we're using a lot of. So here's a bunch of them. And the website generators that I use, this one, view page source. I don't write that. I've shown you this already, okay? This is a Python script that takes my Markdown and turns it into a website. That's it. It's really simple to do. And when you edit in Markdown, let's see, where can I do that? I'll use this. I haven't used this very much, so let's use this one. Let's see how this works. This does not have any X, by the way. So 273L, that's my shortcut. That might be a little hard to see in the back. Can you see that? No? Well, let me make it bigger. Kind of. Okay. This is Markdown. How long does it take you to learn Markdown? On a bad day, it might take you 15 minutes. It's basically you're creating Markdown with these symbols. This is a standard notepad file, txt, and you suffix it with .md. You want to write a novel? There's companies that will take your Markdown and turn it into PDF and sell it for you. You want to write documentation for an open source project? Markdown. It is kind of the way documentation is evolving, okay? And if you write well, you will do well in this career field, because finding people that can really think at a very deep level and communicate with humans, they're sometimes not in the same body. Sometimes there's 2 or 3 bodies in that chain, okay? So once this is written, all I do is I run a script, which looks like this. And this, you won't use this script, you'll use something else. It's called make docs clean or build or something like that. And basically what this is doing is it's going through and looking for all my Markdown documents and generating web pages. That's it. Okay. Yeah. If you want to learn how to use make docs on the Jeremy box, come by on a Tuesday and I'll show you how to get started. Okay. Because it's a little outside the scope of this class. Okay. But it's definitely career ready for you. Okay. All right. Let that go. And then if I had made any changes, I hit refresh and there's my new changes. That's it. Okay. So static website generator. Make note of it. Think about what you want to keep track of. And remember Salvador's advice. Okay. It's a money ticket. Okay. All right. Now, let's get out of this one. And let's close Spice. I think I'm going to use that Google thing and see how it behaves for getting, I'm going to get to the Jeremy box in a slightly different way here. Oops. All right. So basically, this only works on Chrome. This is a beta SSH client that runs inside of Chrome. It's kind of like what we do when we go to the Jeremy box and we click on terminal. This is a Google specific extension that only works inside Chrome. It will not work on Chromium, will not work on Firefox, will not work on Opera. I tested them all. It will not work on Safari or Windows or anything else. It's just Chrome. And it's been in beta for the past 4 or 5 years. So my take on this is the people inside of Google are using this, but they don't want a whole lot of people on the outside using it, or they will have released it to general. But basically, this is just an SSH client, okay? And the reason I kind of like it is it'll make the font bigger, okay? This is what we're going to do today. Okay. This is basically what we're going to do. We're going to talk through the code, and you're going to write the same exact code, and you're going to compile it, okay? Today, hands-on today, okay? So let's talk through the code, and I should probably bring it up in the Jeremy box to show you what it looks like. And HTTPS. So we'll have the same interface. And who am I? I think I'm Tux here. Yeah, this is Tux. I need to log out. I need to log in as me. And I'm going to go to the ASM, and I created a library or a new directory called libs, because basically this is step 1. The C source code, including stdio.h, this is the standard, okay? That's the one you got to use to be able to get to the screen. The second include is the code you're going to write, my header, okay? So grab your cell phone, take pictures, okay? You're going to write this because getting this to work, you're going to be debugging your own typos most of the time, okay? And see if I can make it bigger. Oh, too big. There we go. All right. So let's look at this code. Now, this code is nothing but a very poor demo to explain headers and includes, okay? As a demo, if you take this as gospel, you will be reprimanded severely by your next employer. You do not do what this does, okay? We're just doing this as a quick demo to explain things, okay? So I have another piece of code called my header, and it's going to have some functions in here called add and multiply, and it takes 2 numbers and it does something with those numbers. It's like writing a function, sending it 2 values and returning the value. And everybody knows how functions work, right? Better. Not, come see me Tuesday. All right. And then it says at the very end, bye, see you soon, and return 0. Okay. And notice this little gray thing. That's simply a tab. When you have a editor that is fairly sophisticated, it will show you the difference in white spaces between tabs and spaces, because some programs barf all over spaces, other programs barf all over tabs. Okay, we're talking old school stuff that you probably won't run into very often, but there is a difference between spaces and tab. How many have tried to get their Python code to work with actual tabs in it? Didn't work, did it? Your editor will convert tabs to spaces automatically. VS Code does that for you. You don't even see it. Okay. Okay. So there's one. Now let's go back to here and I'll bring up the header and click on edit. This is what the header looks like. Okay. Notice the void statement. Okay. Notice there's no stdio. Notice there's no main, init main. There's nothing but function definitions. Now, disclaimer, it is not recommended to put function definitions in a header file. Only declarations. The purpose of this code to demonstrate working of header files. Double quotes, exclamation point, yelling at all caps, whatever it takes to get. Don't do that. Bad form. Okay. So what we're doing is, notice we have the word add and multiply, and those words are the same spelling as what's in main. Okay. I'm going to add and then I'm going to multiply. Okay. And then what's it do? Well, it takes the values that come from main.c, or my header, whatever I called it, and it adds them and returns the value through the name of add. Okay. And this does the same thing. Okay. Now, functions and function definitions and how you pass two values to a function and you get one value back through the name of the function is one of the harder concepts in computer science. But if you wrap your brain around that, everything else kind of falls into place. So, being that this is in C, notice there's no C out. It's just printf, and it says, that's my comment in text, human readable. And the %D simply means print it as a decimal. Okay. Because as an integer, I should not see .0. Okay. I can change it to .f and then I'll get all kinds of warning. Okay. So it's just taking the two values, and notice they're called A and B and A and B. Now, why? Can anybody remember the term from their previous programming classes of why I can use the value names that are the same in different functions? Pardon?
You were kind of right.
Scope. If you don't know that term, look up local scope. Write it down on your notes. Local scope. That's why this works. Because A only has a value of A inside of this function. This function is a different function. It's got a different chunk of memory. A only has the value of A in this function. It's called local scope. Every programming language that I'm aware of supports this. Lua is weird. You actually have to declare local. Otherwise, everything's global. Python defaults everything to local. You have to declare a global. Same with C, C++. Local scope is usually the default, okay? So be sure to write that down, because that's a great question to ask an entry level web dev. Can you explain the difference between global and local scope? And if I just got a blank stare from you, I know you're not ready. Okay. So there they are. And let's make sure they're saved. So I make sure it says file saved on here, so I don't get into trouble. Yeah. For the variables for the run the local scope, when does this happen? It depends. Like if you're on Java, it's runtime. Okay. It's actually executed at runtime. On C, what happens, it's compiling it all down to this gas format. And then basically what happens is that gas format stays exactly the same until you actually run it on your different pieces of hardware. Then it will find the memory that's available and use a different memory address. I probably just lost everybody right there. What's happening is we make an executable that will run on any machine. But this executable is smart enough to use memory that's not exactly in the same place on each and every machine. Otherwise, we get a terrible crash. Okay. So it's actually done at a couple levels. Okay. The first level is it's in this generic gas format and the object code. So this is why object code is so much bigger. It says, how do I allocate memory for this particular thing to run on different machines? Now, if we run this, which we will, on the Jeremy box, every single one of you is going to have a different address location where the values of A and B are stored. Why? We're on a shared server and we each get a chunk of memory. All right. Yeah, it's basically, you know, you get it. I need this much, and then it declares the actual during runtime. So it's actually happening a little later. Okay. So let's go into new terminal here. And I'm going to change directory to my Llvm, change directory to libs. Now remember, this is going to be related to your homework that I will assign to you. Okay. All right. It's going to be very similar to this. And this is not a C programming class, so I'm not going to ask you to do tremendous hard work on this stuff. But basically, we're going to take this idea and we're going to refactor it to make it correct. So it will be something you could explain to an employer, okay? So first of all, let's simply look at the compile line that I have on main.c. Notice there's two of them, okay? This is the first one. This just makes it work, okay? Nothing fancy. The second one is the one we need for the debugger with optimizations off, so we can see all the debug symbols and all its glory. So what we're going to do is that I'm going to actually change this to 2. So I'm going to have the first one. I'll compile it to my object code that's been stripped of debugging symbols. And then I'll compile it again, except with debugging symbols. Okay. All right. So all I'm going to do is just highlight this. And do I need right click paste? I don't remember. Does that work? Nope. So you do have to do that. Okay. Let me hit save just to make sure I don't get any headaches. Now I can paste as plain text. So it's compiled. It works. So now if I do /my main, which is spelled wrong, my, okay. It takes my values that are hard coded and it adds them. And then it takes my values that are hard coded and multiplied. And it says, bye, see you soon. Okay. So where did the added value get printed? In the header. Big no. Don't print from your header. So this is one of the things we're gonna fix, okay? Because if you go into a debugger and you're printing this value, it's not in the source code. Where is it? Oh, it's in some obscure library that came from the vendor. Go shoot the programmer, okay? This is not normal. There's a system I worked on many years ago, fired up the system, and it was a new install, and all it said was can't. Just line after line after line of can't. Ugh. It was very irritating. Bring it up in the debugger and find out, oh, the files aren't created, so it can't open the files. Why didn't he say that when they wrote the code? File not found, rather than can't. I wanted to shoot him. It was not fun. Okay. So this is one of the things that you'll have to fix. Okay. All right. So when we compile it and then run it, it's there. Now let's take that second line, this one, and call it my main2. And if I run it, oops. Oh, I know why. I goofed. Let me try that again. I need GC outline AC, debugger symbol. Output C, debug. I think I need my, oh, that worked. Okay, let's see what happens here. Oh, it's my spelling, my name. I can't spell today. So it's the same thing. But now if I do my ls minus LTR or ATR or whatever I want to do, I have an alias called LR. I have two compiled objects. One's 8K, one's 11K. They are both. I can give you my misspelled my main, and it will work on all of your accounts. And every single one of them is going to allocate a different chunk of memory because you're on a different memory segment when you log in. Okay. This is the same thing that happens in Apache web server. You log in and you get things passed through the environment variable that we kind of talked about a little bit last week, that shared memory space that things get pushed and pulled from. So now when we run it, it works. Now comes the fun part. The debugger. So all I want to do to start with today is just bring up the debugger, because we're going to have a lesson on the GDB, and it is a beast. I mean, the documentation goes on for years. This has been around a really long time, and it's got a lot of legacy stuff in it, but there's a lot of shortcuts in it. So we're going to go through basically the Debugger Survival Kit, kind of like learning VI. You only need a few commands in VI to be successful. How do I save the file? How do I get out of the file? How do I abort what I'm doing? Really simple. How do I navigate? The GDB, same thing. We're going to learn how to do very minimal things, set a breakpoint, disassemble it, take a look at the code, okay? Basic survival GDB. Because the concept that I'm teaching you here will work with compiled objects from your language of choice. Rust, C++, C. Java has its own thing. Perl has a debugger, a Perl debugger, excuse me, Python has a Python debugger called PDG that is part and parcel a clone of this one. So if you learn this one, you can jump into that one without any headache. Okay, well, relatively speaking. So if I type in GDB and just hit enter, I get all this noise. This is the copyright. Okay, and if I hit Q, I exit. So how do I get out of GDB? Q. When you're in the world of Linux, sometimes it's Q, sometimes it's Control D, sometimes it's the word buy, sometimes it's the word exit. It depends on the tool. There's no one standard because Linux is, well, say Unix, has evolved over many decades with many different programmers, and there's lots of inconsistencies that you just learn to accept. So now, if I do this again and do GDB and put the letter Q in there, notice it did not print the copyright. Q stands for quiet. Okay, so it just quiets down the thing. So I hit Q to exit. So now I want to play with my object code. Okay, let's use I'll use Q and then I'll use IAM2. Notice it says reading symbols from. How many remember this from last week? A few of you? Okay, good for you. Now, if I hit Q and do the other one, notice it says no debugging symbols found. That doesn't mean I can't debug it. It just means it's a little more work because I don't have things to hang on to my symbols. Okay.
Be able to type that in and flip what you're pulling up.
If you followed my instructions. Okay. Yeah, well, these are the source code. So if you've typed in this and typed in this and put them into the same directory, if those files are in the same directory, you should be able to compile them and they'll work, providing there's no typos. Right. This is going to be very similar to homework I'm going to assign you. Okay, so have some fun with it. Okay. And yes, we are going through a lot of things really quick. I'm assuming you know what the compile cycle is. The source code? Oh, can you open the source code without looking at the debugger? Yes. That's called cat my main. Well, let's do it this way. Cat my main .c. That displays it. Is that what you're talking about? No, you can run it all by itself. You don't have to use the debugger to run it. The compiled object is what you're talking about? Like this one, if I want to run it, Is that what you're talking about? No? Oh, compile while in GDB. No, because you're actually looking at it from a different level. The GDB is the result of the compile. Now you can go in there and change it during runtime temporarily, but you can't. Yeah, that's what security will do. Security will get into a file at that low debugger level and then put their own code into it and then execute it from that point on. So they can, pop a shell or whatever they need to do to maybe reverse engineer a worm or something. But the idea of adding other object to your running code, yes, but compiling it while you're in the debugger, no, not really. Not for what we're going to do here. Okay. I may be proven wrong, but that's fine. I've been wrong before. Okay. So we have the debugger and we have two ways of looking at it. So let's use this one. Now let's just use disassemble. Oops. Have to go to the start. Run. There we go. Let's use R to start with. What does run do? R. Now, the way it works with GDB, you only have to type enough to make it specific. So you can type in the word run if you want, or just R. And what did it just do? It ran it. And it says inferior process. Everybody's going to have a different number because you're allocated memory and processes while you're allocated. Now, a lot of this stuff is way out there. You guys not real familiar with it. I get it. My intent is to make this more hands-on, more exploratory, so you can say, oh, I get kind of sort of what it's doing now. So when somebody asks you a question, have you used the GDB? You'll say, yeah, but. You'll be able to explain the basics of what the tool is supposed to do. Set a breakpoint, run it from the breakpoint, save a variable, inspect an address space. That's all I'm expecting. Those four things. Okay. Now, but those four things can make you a lot of money. Okay. So, all right, let's get this working before we go any further. How many have it compiled? Okay. All right, let's get the compile working. So you're writing two pieces of code, and I can't put them both on the screen at the same time, I don't think. Okay. How many have the code written? Okay. All right, how many are still writing the code? Okay, a couple of you. Okay, let's get the code written and then compile it. Okay. And then I compile, I can bring up a different window. And go into history. Oh, that's not going to work. So I'll move that over to here like this. And go to C. And we'll start with this one. Notice it's spelled wrong, but that's beside the point. Whoops. Okay. So it's now compiled. Now, as you're typing this in, what's happening with the GCC? I guess I should use a different color for the video. More about that later. Every time we jump into something, you think we're at the bottom. Well, there's more. Well, there's more, just like the late night TV shows. Wait, there's more. Okay. This is automatically taking our header file, compiling it, and bringing it into the object code of our main.c. So in essence, think of the source code as being spliced together and then compiled. Okay, that's automatically happening because we are using the same language, using the same compiler. What if my header was written in Fortran and my main was written in C? Can I use the same compiler to combine different source code? No. I compile them to object code, and then I use a linker to link the object code together. Okay, we'll get to that step later. Now, how many have played with a linker in the previous programming classes? That's kind of what I thought. Okay. This, if you have a make file and you compile from source, this make file goes in there and does all this magic for you. And wow, that's pretty cool. What's it do? Well, look at your make file. Okay. I don't know how deep we'll get into that. Okay, but we will know what the linker is. And you'll at least know how to explain what a linker does. Okay. Because for what we're doing, keeping things simple, I don't think we're going to need to know too much of the linker. Okay. So code written and compiled. And then from there, what we'll do is we'll jump into, next week, we'll do GDB. We'll do survival GDB, probably Monday. And then Wednesday, I'll give you the homework, which is a variation on this. Okay. And I'll give you a bunch of clues. So if you're here, you'll be able to figure it out. Okay. I want you to see the process of how all this fits together. And then we'll go back to what we learned on Monday to play with your homework and change some values and memory segments and see what happens. Maybe not memory segments, but we'll change some values, see how things work. Change a string. Okay. Because this stuff, I honestly can say I did use in industry. Writing actual assembler and moving things to registers, I didn't. Okay. I used C when I needed to get to that low level. Okay. I wrote this really cool interface that took a keyboard and an old, I remember those Daisy printers that had the little wheel in them? Nobody? Okay, well, just think of it as a printer where you could actually type on the computer and it would go to the printer like a typewriter. So I mimicked the typewriter and I used that as a diagnostic tool because in those days of printers, sometimes you'd get a character that wouldn't print and you had to find out if it was the stepper motor on the header or if the little daisy wheel thing was broken. Okay. So it was kind of easy. Wasn't too difficult. Standard in, standard out stuff. All right. Let's tinker. We got 15 minutes. So let's get it working, get it compiled, get it running. Why don't you do something different, like change 4 and 6 and 5 and 5, change it to something else. If I make the change, what do I need to do? Recompile. Otherwise, it won't work. I have to recompile my code if I make any changes. Okay. All right. So let's add a couple zeros to these things. Let's see if I can have some fun with this. And I might very well end up with an error because I'm making it too big for the register it's supposed to fit in. You can overrun your buffer. This is a classic exploit where you stuff a value that's not supposed to be that big, and it can, depending on how the code's written, you can end up SQL injection 101. Write a bad SQL statement, take over the computer. Okay. All right. So it's saved. Let's do my compile again. I'll use that one. Didn't die. Yeah, all I did was change the source code. Yeah, where the numbers were 4 and 6 and 5, 5 respectively, I just made them 40, 60 and 5,000, 5,000, which are still within the spectrum of an integer for C. How big is an integer for C? 32 bits? 64 bits? Does it depend on your architecture? It's relative. Now, if we look at this in memory, are we big Indian or little Indian? We're on little Indian machine, Intel architecture. Remember, things will be stored in the registers all backward. So you have to kind of reassemble it in your head. We are covering a lot of stuff in this class. So, all right, get it working, change the numbers, compile it. You're comfortable with it. That's all we're doing for today. If you got questions, holler. All right, thank you. And if you want me to bring up the code, do the same thing with Rust. Run it in the debugger. See if it lets you do it. Rust may not let you break the rules like this. Yes, sir. And what kind of error is it getting you? Yeah, so look in your header file. Look how you spelled multiply. Look how you spelled multiply in your C source code. Computers don't care if you can't spell, as long as you can't spell consistently the same way. Okay. Not the right number. Did I get an error? Welcome to, what if this was payroll? You owe the company a negative $168 million? Yeah. What that means is I've overflowed the buffer. So my integer is allocated X, and I made it too big. My only error is it's a negative number. It didn't die on me saying, hey, invalid calculation. Now in Rust, that would be caught at compile time. And some of the tools in Clang and C++, you can turn on extended warnings to avoid this type of overflow negative. So you can actually set things. C lets you do bad things if you want to. So in one way, we can say we did a bad thing on purpose to see what would happen. Okay. That is by no means that times that. And this is mentioned in the ZY book about flipping over and rolling over when your values are too big and it won't fit. Okay. The right answer is not stored anywhere because it thinks that that's the right answer because you've allocated this many blocks of memory to it and it used this many and it just put what it thought was there and it thinks it's right. Right. Now, here's one of my little soapboxes that I get up on. I stood up on my soapbox here. Data validation on the way in. Data validation on the way out. When you're writing code where people type stuff in, you better make sure you can take keyboard and sit on it and it won't take a bad value or you're going to have this kind of problem to debug. So you want to make sure that if you're asking the customer for an integer, they truly only type in an integer. Okay. Data validation. Because once garbage gets shoved in, yeah, we'll know how to fix this. But what if it was, a payroll system, all of a sudden the boss just got a big payout. He got a golden handshake and he gets a negative number. Who's going to fix it? Let's see, next week there is.